And so now, what do we have? Well, I have two different series that have the same index for different categories of values. The first series has population. The second series has area. Okay, but I'm using the exact same index value. And so clearly what the information that we're conveying is this type of rectangular data, right? So if we think about how how we would interpret this, you can think of this as a set of states, and I have two pieces of information. I have an area and I have a population. And this structure is what we would refer to as a Pandas data frame. So a series has a one-dimensional array with flexible indices. So you can have numeric indices, or you can have key-based indices. As we'll see later on, we can have more sophisticated types of indexes also. The data frame is a two-dimensional array with indices for the rows and indices for the column. Okay, and these columns are all aligned based on the row indices. Okay, so in other words, they share the same index as we would expect for this type of rectangular data, right? If I want, I'm trying to compare the area and the population of different states, and so I need the values to align based on these row values. Okay. Questions for me so far? Okay, so we can create these several different ways. The easiest way, since I have the two series, right? I have a series called population, and I have a series called area that we just created. So I can create a data frame by just specifying those two series. So I've specified the two series, and then I have to say, here's what the column index is, or think of these as column names. And so by executing that data frame call using the dictionary with a key value, and then, or I'm sorry, with a key and then a value as a Pandas series, then I create the Pandas data frame that we're interested in. And I can look at the index. So my index here is California, Texas, New York, Florida, Illinois, exactly what we saw before. I also have a set of columns, and my columns are area and population, and note that this is also defined as an index. So as we said, the three fundamental data structures in Pandas, there's a series, which is, you can think of that as a one-dimensional array. We have a data frame, so you can think of that as a two-dimensional array where the columns are not homogeneous, so I can have different types, and the index. And we use two different indices. We have an index for the rows, in this case, California, Texas, New York, Florida, Illinois, and we also have an index for columns, in this case, population and area. And then if we look at the values, then we have an array. So we have a Python array of the values, and these are all type int 64. Okay, and then of course you can look at all the types, and as I've already mentioned, the index types, the states index and the states columns are both index types. Okay. So by using the column name, we can extract all of the values. So one of the two series, so if I just do states area, where area is one of the column indexes, then I get that column. I can get the second series if I use the population column. And I can look at the types of these, and you can see that each one of these is in fact a series. So these are, in Pandas, are built on top of each other. You have NumPy arrays, which store the data. We have a series, which takes the NumPy array with the values and adds to it an index. Then we have a data frame, which takes a set of series and applies a column index, right? So fundamental components are the exact same. You've got the series, I'm sorry, the NumPy array, the series, the data frame, and the index. Okay? Questions for me so far? Okay. So with our column, let's just add another column. So we just follow that exact same process that we did earlier, and then I'm creating a new series, this time called color. So I have the same index, and I have blue, red, blue, purple. And so we can add our new column the exact same way that we saw when we add components to our list, to our, I'm sorry, when we add components to a Python dictionary. I just give it the new column title, or the new component of the column index is what it will end up being. And then I give the corresponding values. And you can see that we now have a 3-column data frame with population, area, and color. And note that the array values are now type object. Okay, so where we had before, when we scroll back up here and we looked at the values, where did I look at the values here? Somewhere up here, here they are. When I looked at states.values, when we only had area and population, the data type was int64. So we never said type int64, right? When we created it, it was implied, right? So when we created the Pandas data frame or the individual series, the type int64 was inferred. And so the corresponding array for the 2-dimensional, or the one with the data frame with 2 columns, is still type int64 because everything in it, both of the series, have that same data type. When we add a object type or a string type, you can't have that anymore, right? So now I have some of these are numeric. So I have my 2 integer int64 column, but I also now have my object column, and so it has to upcast the value structure, the set of values, to be that to be of type object, because we can no longer have type int64 because I have these numeric or these string values. But if I extract the individual series, right? So if I look at the individual series, like states area values, which is just the area. Remember, states area gives me the series. So if this is the series value, it's type int64. States population, it's type int64. And the state's color, it's type object. So while if I say, show me all of the values in the entire data frame, it's upcast to objects, the underlying series are still there, and they still retain their corresponding type. Okay? Questions for me on that?
So what is the type of color? String?
It's type object. So if you look at type object right here.
Oh, so it's not string.
Right. So so in NumPy and in Pandas, it represents the data type as object, even if it's a string.
Okay.
If I look at an individual component, so if I go, let's just go and insert cell below, and let's look at, I don't know, state. Let's see, what do I want to look at? Let's look at color val. Oops. This is not. Not being responsive here. States, color. Can't type today. 0, it's blue, right? And so if I look at this type,
There's a typo.
I really can't type today. There we go. it's a string. So the individual element, right, the individual element of our states, colors, are strings, but the numpy and then the series data type is upcast to objects.
Okay.
Okay? All right, so the last thing I want to talk about today, I want you guys to do some experimentation with this, so we're not going to get too far today, is this third fundamental data type, which is an index. And so I've got the definitions from the Pandas documentation. So immutable IND, so immutable numpy array implementing an ordered sliceable set, the basic object storing access label for all Pandas objects. That's the definition of what an array is. And so the important part here for us is that it is a numpy array and that is immutable. So I can't change an index set, an index element once I create it. Okay? So it's immutable. It is itself a numpy array, or includes a numpy array, but it implements an ordered sliceable set. So as we saw when we had state names and when we had the alphas, not only can I use the index like a key in a dictionary, but I can also slice based on that position. So that's where the ordered component, the ordered part comes in, is it lets me not only reference individual elements using the value, like Illinois or Texas, but it also lets me select or do a slice by using this notion of an ordered set. Okay. The last component of this definition is this notion of a set. So these things are unique. So I can't have an index that includes, say, row A, two row A's, right? Which we can have in normal Python lists, right? I can have multiple values. Remember, when we differentiate between a Python list and a Python set, the set has unique values. Same thing here as part of the index. Okay. And so this index object is a fairly complex data structure. You know, we only kind of touch on the very basic components of it, saying that it's this ordered sliceable set, but it's an interesting data structure in and of itself. Okay, and so this design, from the series object to the data frame object to the index object, these are all designed to facilitate different types of data manipulation operations, such as joins across data sets, where I'm doing not just adding two data sets together, not just concatenating, but I'm doing set arithmetic. So I'm trying to do comparisons and things like that, which we will see going forward. We're going to see how that works. But I just wanted to point out here that that's really what it's built for. It's not just built to store rectangular data as a storage, which we can just do with a list of lists, or we can do with the with other different types of data structures. But what Pandas also provides is the mechanisms within the class definitions to do sophisticated data handling.